This is the world of your brain. A dark, silent place called the inside of your head. The only way your brain can perceive the world outside your skull is through highly specialized remote sensors located throughout your body. When an event takes place, the sensors relay the information by electric signals sent along the nerves. The sensors detect vibrations in the air, the motion of the body, intensity and color of light, an incredible amount of information.
To the land of sun and surf, Hawaii.
The sensory organs of the body tell the brain about a place it cannot go, the outside world. In the same way your senses relay information to the brain by electric signals, transducers act as senses for technology. They detect activity and represent it in some form of information. The information tells the technician, or a controlling computer, about conditions inside the machines. The signal from a transducer is often electrical or mechanical and is usually represented by a meter. What the meter has sensed could be speed, pressure, voltage, or temperature. Transducers provide precise information about events that are taking place in areas we cannot enter with human senses, such as the inside of a nuclear reactor. Or information about events we cannot see, such as the flow of electric current through a circuit. Technicians using transducers are, in effect, using another set of senses, which let them see inside technology in operation. Your senses have both an input side and an output side. The input might be touch, which can detect temperature differences. The output is the signal that travels from the detector to your brain. A transducer, like an electronic thermometer, does the same thing. A probe detects the temperature of your body and translates that into a signal read out by the gauge. Transducers are like energy converters because they have energy on the input and energy on the output sides. Transducers appear in mechanical, fluid, electrical, and thermal systems, and like energy converters, we will classify them according to the form of energy on the input side. So what's the difference between a transducer and an energy converter? Energy converters, like engines, try to convert as much of the input energy as possible into another form. A transducer is only there to measure the process, so it uses as little energy as possible, just enough, for example, to move a needle. If it uses any more energy than that, it will disturb the system it's trying to measure. So a tachometer does not rob an engine of energy. It merely uses an insignificant amount of that energy to provide a signal. Tachometers and speedometers are mechanical transducers because they detect mechanical motions and represent them as RPM, miles per hour, or kilometers per hour. A pressure gauge is a fluid transducer because it measures the condition of a fluid and represents it as the position of a needle on a scale, PSI, pascals, or Newton per square centimeter. A multimeter is an electrical transducer which detects current and gives output readings in volts, millivolts, amps, or milliamps. And a temperature probe is a thermal transducer because it senses temperature and represents it in degrees Fahrenheit or Celsius. It is through transducers that technicians are able to maintain equipment, as well as ensure that it's running at peak efficiency. They're also valuable when troubleshooting. Bruce Crabe is a technician who maintains automated equipment at the Ontario Science Centre. See if you can predict the type of transducer used in his process.
This is raw ABS plastic. We use it in an automated injection molding assembly line to make these plastic key rings. The whole assembly line is controlled with transducers, an extra set of senses for me and for the controller. First of all, the plastic has to be dried in this desiccating dryer. The dryer is controlled by a thermocouple. Then the plastic goes into the injection molder, where its temperature is controlled, again, by thermocouples, precisely so that it's injected into the cavity mold. Once the parts come out of the injection molder, they're picked up by the automated assembly line. A set of suction cups picks up each pair of parts. The suction cups are connected to vacuum transducers, so the controller knows that it has picked up a part. The plastic parts are then put on a weigh scale, where they're weighed as a quality control measure. The weigh scale uses a load cell type transducer. The parts are then transferred to the hot stamping machine, where they're written upon using a combination of both heat and pressure. The temperature is controlled by thermocouples again. So this system is dependent on transducers, and I'm dependent on transducers to know that it's actually working correctly. Without transducers or an extra set of senses, the automation would not function.
When a problem develops, some people feel that the first thing you should do is take it apart.
Mister, my car's running a little rough. Can you take a look at it?
Oh, sure. It looks, oh, you mean under the hood? Let me look under the hood. I'll check it for you.
Okay.
Could be a problem with the catalytic conversion. Oh, well, look, this isn't right. Put in your car here. This doesn't belong here. This should be in the rear end by the axle. We better put that in later, but let me move this and I can get a better look at the fuselage under the campaign motor. Can we pull this up? Oh, that's a big problem there.
Approaching the problem first with transducers saves a lot of time and usually a lot of money, especially when the problem is much simpler than you thought.
First, because see, that runs that like around like that. See, there could be one other thing. Let me check. Let me check. Need a minute. This eventually will have to go because
Do I need that?
shit. Well, you might sometime, but not right now. Well, wait. You know what your problem is here? Let me check. Hey, lady.